We are at the Big Data Expo in Utrecht, where I'm speaking with Kristof Neys, Director of Graph Data Science Technology at Neo4j. Welcome, Kristof. You're all the way from London here on the expo here in Utrecht. When I mention your job title, Graph Data Science Technology, that's a bit of a new combination, isn't it?
Yes, Werner, and thanks for having me. It is indeed. And so let's unpack that a little bit. So what do we actually mean with graph data science? It's ultimately a combination of a set of graph algorithms, and those graph algorithms have been developed in sort of like in the literature and research for decades on end, like with basically the bridges of Königsberg to kick it off with, so to speak. And then we have recently, so like a whole new set of graph machine learning models ultimately, and it's a combination of both. It's a combination of a set of graph algorithms plus the graph machine learning, graph neural networks that we call a graph data science ultimately. And then, so that is ultimately the set of models and algorithms, and then we're deploying them on a knowledge graph. And the knowledge graph is really a very rich and structured representation of your data as entities, the direct and explicit relationships you have with them, and then indeed basically properties or semantics that you've added to both those entities and the relationships. And then once you have that sort of like rich structure, data structure, it makes sense to gain ever further insights into that data structure, and that is indeed where these set of algorithms come into play. And all of us, and certainly you and I, Werner, we probably use a graph algorithm on a daily basis. PageRank. Every time you do a Google search, you deploy a PageRank. Now, if you can deploy that at sort of like industrial scale on your knowledge graph, that really adds a lot of insights in your data. And it's by structuring your data as a connected form that you can gain those insights, that you can learn from those connections. That is not at your disposal. It's not possible if you leave your data in a tabular format, right? So that is really where this power of this, what we call the graph data science technology, really plays into on that knowledge graph concept.
And what does it actually take to construct a knowledge graph? And can you mention some use cases perhaps?
Yes, absolutely. So as I mentioned earlier, so you will structure your data in terms of entities. So entities could be explicit entities. These could be your customers, your person. This could be your tennis club, who is the tennis players, etc. Then you have the relationships between those entities. So those are the explicit connections that you have. Again, the tennis club, this could be the matches between people, this could be customers that have bought certain products, etc. And then what you want to do is to construct and to add some more properties around those entities and relationships. And then the use cases that you can do are very, very varied. So we have built use cases for NASA, where we've constructed a knowledge graph around ultimately tests that they have done, so the test documents, connected all of the links, the successes and the failures. These guys managed to save a lot of money and, as we say, got their mission to Mars quicker. Fraud is a classic example. So fraud cases, people, baddies effectively committing fraud. Well, that is a connected graph and a connected network, and then by deploying the graph data science library, you can increase the level of fraud detection and certainly finding much more suspicious activities. And then finally, building digital twins. A digital twin is a classic use case of application of a knowledge graph. So those are kind of like, it's very varied, from fraud to NASA to etc. to those kind of use cases.
Well, fraud detection is one of the most widespread use cases indeed. What are the advantages of combining a large language model and a knowledge graph?
Yes, that's a good question, because of course now in this day and age, who hasn't been using ChatGPT or the GPT engines? So the GPTs are fantastic, are very, very powerful, trained on trillions of tokens in some cases, and so very useful. But the problem as well that they're facing is they can make things up. You know, there was this case of a lawyer in the US who basically supplied some cases to the court, and everything was made up. So they have this problem of hallucination, right? And they have another few drawbacks. That is to say, they have a cutoff date. You can't really have explainability around it. So what you can use now, a knowledge graph as sort of like the source of truth for the language model. So you restrict effectively the knowledge base that the language model can deploy, can use, to a knowledge graph. And knowledge graph provides you factual information. So what that does allow you to do is to make sure that whatever answer you get back from your language model is not hallucinatory, you know, that you can update it to the latest at the minute most information that you have. have, you obviously have explainability around the answers that you can get from the language model. So there's a variety of real benefits in using a knowledge graph as grounding or retrieval augmented generation. So those are kind of like the main benefits. There's a bunch of other things, but I would say that's a really powerful application.
How can you augment a knowledge graph by using a large language model?
Yes, that's another one of those, so like reversing it now, so to speak. Now, one of the real benefits that you have from this language model is the ease you have of, for instance, providing encodings, word encodings, text encodings. You literally have one simple API call that is so easy now to gain, and you can convert a description of a product, description of a component, etc., to a vector. And what you can do now with Neo4j and the knowledge graph that Neo4j as a core object provides, you can write it as a property to each node. You can write vectors to each node. And another feature that we just have released is that we can basically provide indices of on these vectors. That allows you to provide vector search, similarity search rather, on those properties in your knowledge graph, and then what you can then do by doing that, you also can get the context, that is to say the neighborhood around those nodes where you've now searched on these properties, these vectors, and you can get the context. So not only a similarity search, but a context search. So that's really one of the powerful augmentations you can get from these language models on a knowledge graph in a graph database like Neo4j.
And in your opinion, how will this develop? There's a lot of new technology, a lot of new possibilities. How will this develop, and do you have some practical examples?
Yeah, sure. So I think there's like you just said, like there's a bunch of, it's every day is a new development. But I think what's really exciting now is also that you can use these language model, a particular application that they do is called named entity recognition. And so they can actually take a piece of unstructured data, text, analyze that text as it were, extract the entities and the relationships out of that, and you can instruct the language model to be extremely precise. So named entity recognition was a method used in NLP already for some time ago, but you can now be so specific with regards to the language model to say this is an entity, this is a relationship, and in addition, it allows you to determine the exact output. So you can say, return it to me to a pandas data frame or JSON file or what have you, allowing for very fast ingestion in a knowledge graph. So you have automated knowledge graph construction. Now that is really powerful because most organizations, most companies are sitting on millions of documents, etc. And that is effectively stranded data. That is to say, no one is going to spend their bedtime reading these documents. If you now have an automated tool that ultimately can construct your knowledge graph and hence transfer your unstructured data to structured and make it now insightful, that is really powerful. So you can imagine all of the basically stranded data, all of the insights that are now suddenly are usable and visible. So I think that's a very first application and easy to use. And of course, then these language models will continue to develop in quite large fashion and be more ubiquitous, so to speak. But I'd say the application of the application of automated knowledge graph construction is a very exciting and immediate implication. Yeah. So.
Indeed. Well, thank you very much, Kristof.
Very welcome. Thanks for having me.